This stuff is amazing. Good stuff. Blueberry, blackberry, strawberry, banana. Even matches my shirt. So today we're going to be going over a board that is completely dead. It's an 820000164. Now, as you can see, no light in the charger. You can't see that because even though this room is completely dark, the light decides to reflect right off this. So I'm dark, but this is... Anyway, you can take my word for it, no light. Now, in order to get the light, we need a couple of things to happen. As I've gone over in almost every single one of these videos over the past 2.5 years, you need PP3V42 to be present. So let's measure PP3V42 on this board. Now, I'm guessing this is liquid damage. This has been cleaned off by somebody else who does this type of service. And what they usually do is clean it off, get rid of all the traces of them cleaning, and don't leave any memo as to what was originally damaged. Because that would make it easier, you know, and then they want a discount. Is that any wonder I don't offer, like, you know, more competitive wholesale business rates? All right, so let's see. So we have 16 volts coming in. We have 16 volts coming into the PP3V42 circuit and 0 volts on output. Now, next thing I do is I check to see if there's a short to ground. Red probe on ground, black probe over here. And we have no short to ground on output. See, this would be more like a short to ground. See, when they're both no resistance, no voltage drop, perfect connection. But here so let's check out that area. So not only can you see that there was liquid damage over here it's already been cleaned off, but again, you can't hide from me. You got this, you have a broken, this from here to here is broken. This chip over here is kind of fucked. And over here you can see where a piece got knocked off. See this? Resistor got knocked off over there. That makes me so sad. The toothbrush. Remember, use alcohol and a toothbrush and scrape as hard as you can. Who gives a fuck about the components on the board? You don't need those things, they're optional. I would love to see more thinking. I got my hot air station over here. It's off. I am getting excited because it's the holiday season. And the holiday season means people buying shit. And I have an Amazon affiliate account, which means if you want to show your loved one just how much you care about them, you can buy them a HAKKO rework station as described in the links below. And we will get a commission as a member of the Amazon affiliate program. And even if you don't want to show how much you love the loved one in your life by buying them a HAKKO rework station, if you don't think grandma wants an Amscope or a HAKKO rework station, if you click one of those links and buy her something else, television, jewelry, who the hell knows, as long as you click one of those links and then went to Amazon, I still get a commission. So I'm curious how that will turn out. I am curious to see how the holiday season as an Amazon affiliate will work out. So see this is clearly broken. And the thing is, these are not coated. So for example, like see this trace over here, this is coated. So it's not, you know, I can't get to it easily. I can't really like scrape it or anything easily. I have to scrape hard. Whereas these probe points here, you see these points that are just like copperish looking? If I do this, I can easily get to it. So every one of those points that I can easily measure is it's a good thing that I can easily measure it, but it's a bad thing that that it's not coated with anything. Since it's not coated with anything, it's easily damaged in the case of water. So that's why I go over these points around, the weakened areas with solder. Just because it's harder to harm that. Anyway, so I'm going to have to run a wire from here to there. No biggie, no biggie. So what I'm going to do here, I like to show what I use, because honestly, a lot of this, it isn't even really the skill required. It's just not knowing what the fuck you're supposed to use that keeps you from doing this stuff. So I'm using the battery that I got from an A1286 2011 and 2012 machine. What I did is I cut the wire. So I keep the batteries when I replace them, and I cut all the wires before I send them to e-waste. And then I strip it down, and then I have these little individual strands. So it looks like this. See? So that's the wire itself, and then here's the individual strands. And I use the individual strand, and I'm going to run that from here. Okay, this is going to require tweezers, because that area is a pain in the ass to get into. So... I gotta grab it right from the end. Come on. Now I have solder on my iron, so I'm gonna add flux here, and then that used up solder on my iron will transfer. Hopefully give me a nice solid joint there. Or not. Yeah, my hands aren't doing good with this today. There we go. Now we're just going to do this. And see what I got there? I just reconnected the point that was broken off. Beautiful. Now I'm going to take some stuff off of the donor. Now, the other thing that makes this all possible is having donor boards available. Don't discount the importance of a donor board. They're very, very important. Having all these parts nearby is what makes this possible for me. It's why I don't bother fucking with no fix, no fee repairs of other stuff. Not having to order something and wait a week, order something, wait a week, order something, wait a week, when the customer wants it back in 2 days. No, the way I stay competitive is having donors. So I'm going to take the IC that I need from a donor, the 2 capacitors that I took off from a donor, and then also the resistor that was missing from a donor. Push down. Nice and on there. Also, by the way, this is another reason that I usually work at a low zoom. So right now we're at about 13x. When I work at 7x, see, I can move it up and down on them, and it doesn't go out of focus as easily with, differences in the height of the board. Whereas it's very much more sensitive to changes in the height of the board if I work at a higher zoom. So I try to avoid higher zoom altogether. It is useful every now and then to be able to zoom in a lot, but I don't do a lot of work with really high zoom. Okay, we got some nice joints there. All attached nicely. Now this chip needs to receive more than 2 volts on its SHDN pin in order to turn on. The SHDN stands for shutdown. If it has less than 2 volts on that pin, it doesn't turn on. So this is the 16 volt input into the chip, right? There's 16 or 8 volts depending on whether it's being powered off the battery or the charger. And that resistor goes between that 16 volts and that SHDN pin. Now since that resistor was missing, you would have had 0 volts on the SHDN pin, which would tell it to not turn on. That combined with the fact that the 16 volt input to the chip was not getting to the chip because that because that line was burned, and you get the fact that it was dead. We can make that look better in a second. Remember, those two are attached to the same point, so this is totally fine. Now we can just get everything rolled into place. All right. Now, those two capacitors are crooked, but that's a hallmark of my rework. That's my warranty sticker. Some people have a warranty sticker. I have stuff that's out of place. It's what I do. It's how I know that I did it. It's unprofessional, as the trolls will say, and fuck it, I don't care. Now, let's plug it in and see if we have any improvement. There is no improvement because I forgot to replace this stuff that's obviously blown. So there's 16 volts here, but yeah, what are you doing, dum-dum? Don't turning off your rework gear like you're done. You fucking idiot. All right. See, this can be powered off of the battery or the charger. It can be powered off the battery or the charger. And it goes to here, and then this stores the voltage, and then that creates the 3.42 volts from the 8 or the 16. Simple little circuit. The in on the right and the out on the left. Simple little circuit. I thought I was done. I even turned off the iron. Come on, get hot. Come on, melt solder. Melt solder. Come on, melt solder. I can't believe how impatient I've become. I mean, I feel like it was just yesterday that I was using an iron where I would turn it on, go to take a piss, come back, it would be half as hot as I needed it to be to melt solder. Now it's like, turn on, turn on, turn on! Well, it's time to wait. Who waits for their iron to heat up? Not me. I hit the button and I want to get working. Alright, now I gotta get another resistor. Ay. Okay, now that I actually did my job, let's see if we have any positive change. It lights. My fan spins. I mean, the fan spins. Is there really anything else to this whole thing? So let's go over what we did, what was wrong, and how we fixed it. So let's open up a board view and also open up a schematic for this tiny board. It's 00164. All right. So let's take a look over here. I'm going to open up the board views side by side with it. If I ever find it. There we go. Okay. So these two caps, C7091 and C7090, look nasty. Now these are capacitors on voltage in, and they go to ground. Now these capacitors could have shorted to ground because they look disgusting, and them shorting to ground would explain how these resistors were blown. So this resistor limits current from the battery, and this resistor here limits power from the charger. This circuit can be powered off the battery or the charger, and this diode is here to keep the power from the charger from going straight into the battery, if you have the battery and the charger plugged in at the same time, which is often the case with a laptop. Now, so if this shorted to ground, this would kill these two resistors. These are the two that I replaced in the end that look really nasty. Now, there was a line between over here and over here, which was blown. So this chip was not getting any power at all. Now, regardless of how this is drawn to make sense for us, but the way this is actually put together is the diode goes to the capacitors, and the capacitors then go to here. It makes it look like the diode goes to here, and then this goes to the capacitors. That's not the way it is. And the board, as you saw, this diode has power going to the capacitors, and then the capacitors go to here. So I redrew that as a wire. Now, what I was also missing was a resistor between the capacitor and the SHDN pin. I saw that solder was ripped off. And what this does is it brings the 16 volts over to the SHDN pin. Without this resistor here, even if these capacitors weren't shorted to ground, even if there was a trace in the board from here to here, and even if these resistors worked, nothing would have worked. So if we look up LT, whatever, my brain is dead, so I'm not going to read that. Even if I look that up over here in my web browser, you can do it, computer. I know it. You can open a web browser and encode video at the same time. I have faith in you. I have faith in you. You can do it. Oh joy, it looks like something has been installed that I don't want. I don't know who you are, so I'm not going... Yeah. Alright, time to... I'll erase that shit later. I'm pretty sure I never installed that. I think that's a leftover from when I installed Driver Pack, because I was too lazy to download everything automatically. Anyway, let's look for the shutdown pin. So I just Googled the number of that chip. And let's see. So SHDN over here. SHDN. Let's look for the pinout. All of this is for people who went to college, who, can actually design things, who have real purposes in life, not, fuck-ass repair people. So I ignore this altogether. This is for people who are smart. We just go past that. This is for people who are smart. We just scroll past this. More stuff for people who are smart. And this is the section for idiots like me. This is the section where they tell you in kindergarten print what everything does. So the shutdown pin is used to put this in shutdown mode. Tie to ground to shut down. Apply 2 volts or more for normal operations. Let's think about this. Tie this to ground. Now, what voltage is ground? Ground in the purpose of the circuit is 0 volts. So if there's 0 voltage shutdown pin, shut the circuit down. Apply 2 volts or more for normal operation. Normal operation is when it's just, working and creating 3.42 volts. So If the shutdown feature is not used, tie this pin to the voltage in pin. We're not using that, so we simply tie this to the voltage in pin using a 0 ohm resistor. So if that resistor is not there, I can jump to the assumption that if this resistor is not there, that this circuit is not going to work, it's not going to boost. So we replace this chip because its voltage in pin looked destroyed. We replace these two capacitors, which were most likely shorted to ground and input, and we also replace these two resistors that blew because they were limiting the current from the battery and the charger while this circuit was shorted to ground. So after all that was done, we get a nice green light, and it works. So as always, I hope you learned something.